Johnny Gordon from Iconic Construction. Hey, just want to give you a bit of an update on a cool project that we've been working on around 3D printing of concrete walls. So this is a product that's made locally here by a company called QOROX. We've formed a regional partnership with them to install and be the preferred building partner. This product is made in a factory locally here in Hamilton. It's done with a robot. It squirts it out, and as you can see here, it comes out in layers and builds up the walls to be able to get to this height. So as an example, this is done in a factory. You can see with it's done here, so it just sits onto the foundation. The layers are poured on top of each other, and they're about, I don't know, 10 or 12 mils there each layer. This wall would get printed in about 30-35 minutes from the bottom to the height, full height, and then it's just wheeled out of the way and another trolley's moved into place to be able to start printing the next wall. Best we got on these was from hooking onto the truck to in place to back to the next one was 22 minutes. We reckon we'll get that down to 10 or 12 minutes per panel. This is the finished product. It's just got a sealer over the top of it. Exactly the same as tilt panels. You can see there, a bit of perf rod in it and then silicone in between it. And that's basically the finished product. You can put colour through it, an oxide, to be able to get it a different colour if you want, or you could paint it. We've just gone for the natural look, which is the most cost effective as well. So this is having a bit of a look inside, so exactly the same effects. This is what the client wanted, this is what we were hoping to achieve. So this is actually a two-walled system, three-walled system, sorry. So it's got a wall on the outside, wall in between, and then this surface here. On the wall on the outside, it's got some reinforcing bar in it and filled with concrete. And then between this wall and the middle wall, it's got any surfaces that we wanted to pop down, and then insulation, some polypropylene insulation shot into it. So really cool effect, and we're really happy with how this has come out and going to look.
So generally speaking, it's speed and durability. So what ends up happening is that you get a more durable final product at a similar price point and a very high speed. The average time to build a house in New Zealand is around 9 months. We believe we can shave around 3 to 4 months of that. And when this happens, you immediately increase the house stock and make it more resilient. And also, it has also a lot of applications when it comes to infrastructure and commercial building, site landscaping, and generally speaking, you can have a more durable asset that will last for generations rather than having it a short term. So the material itself is a special material. It has 30% less carbon footprint to traditional concrete. And the materials mixed here in New Zealand, 80% that comes out of the robot's nozzle is locally sourced. And it's also developed particularly for the New Zealand climate and New Zealand local material. So we got a grant from Callaghan Innovation to develop the New Zealand material, and we developed the material literally an hour away from where it's being used. And this creates a parallel supply chain that makes the industry more resilient and prevents a lot of the choke points that we have in the current supply chain. It could be used for housing, it could be used for commercial building, it could be used for infrastructure, it could be used for ramp protection, it can be used for flood protection. Also, there's massive applications for it for landscaping and public spaces. So it could be used for anything that we really need to have a product that will be resilient and will stand the test of time.